gentlemen, ready to continue?
Yes, Mr. Yes,
Good.
Mr. Ahmed, can
Good,
continue.
good food?
Yeah, Alhamdulillah.
Okay. Okay, gentlemen. We'll proceed. So now we talked already about the CompBUB. This is the CompRAM assembly. Dual. You will find shear and seal. The shear is above and below is the blind or seal. And this one is in the top one is slip, and bottom one to seal from the hole is the pipe RAM. This is the triple POP equipped with 3 sets of RAM, which is rare configuration, is not common type to use. Top one is blind, shear, pipe, and slip together in the lower RAM. The same configuration, pressure sensor and equalizing valve, port for the killing operation. This is the operation for the RAM. Hydraulic fluid or pressure from accumulator is sent to the opening and the closing chamber to push the RAM to close. There is one line to open, push the RAM away, and second line is to close. So usually in RAM, this is the RAM operation for the coil tubing. Here is the weep hole. What do you know about the weep hole? Any answer?
To be honest, Mr. Ahmed, we don't know about the. I don't know about the weep-hole, but maybe if you explain what is the weep-hole, maybe we know it in a different term, in a different terminology. I have solved some questions in completion operation as well regarding this weep-hole, but they didn't understand what is the weep-hole actually.
Okay, weep hole, you will find the weep hole in sealing, in any sealing gram. Okay, you have shaft here to push, and this is the piston, hydraulic pressure to push, to close, to seal ram around the pipe or the coil tubing. Okay, this is the area for the well, and this is the area for hydraulic pressure. There is here something called port or weep hole in the body for the ram, in the flange. So this one, if you make pressure test and you find any leakage or droplet for the water or oil or fluid from the well, this indicates that there is primary seal here for the shaft is sealed or damaged. So at that moment, you need to release the pressure and replace this seal immediately without any delay. This is the opening chamber, and this is the closing chamber for hydraulic fluid. If this one weep hole is not fine, that means the pressure of oil or gas from the well will start to going through here. So it will contaminate the hydraulic oil in the opening chamber. That's why this weep hole give you indication there is internal leak inside the ram. Please release the pressure and take immediate action to replace this seal. In another side, there is another seal here. If you have leakage from this port, which is hydraulic oil, that means another seal, another side is leaking also. We need to replace this side of the seal. So the weep hole indicate leaks inside the internal of the body for the ram. This is the function for, sometimes the weep hole is called drain hole because it's drain the fluid from to atmospheric to the atmospheric at the surface. Okay, gentlemen.
Yes, Mr. Ahmed. Thank you so much.
Thanks. Tertiary barrier now is single ram BOB, which is called shear seal or sometimes called safety head or safety BOB. This is the Why we need to install this one as tertiary barrier? To increase the capability for securing the well and shearing the pipe. If you have any leakage below the quad BOB or below the shear seal, so you will cut the pipe with shear seal, which is installed above the Christmas tree direct. So, and after that, you drop the coil tubing inside the well, then you close the Christmas tree valves to secure the well. So, single ram cable of shearing coil tubing, sealing at the same time to provide well pour isolation. Usually here, according to the policy, used in high pressure gas well beside the normal BOB, classified as tertiary barrier. According to the API, in some cases is used as a spacer spool or shear seal.
Mr.
As yes,
Another question. With this BOP, which we are like a shear seal BOP, can we cut only, or the rams can hold the pressure as well?
yeah, it's cut and it's have seal, okay, top seal and front seal to seal the pressure for the hole at the same time. But at that time, when you cut, you will lose the coil tubing inside the hole. It will drop in the well.
Yeah, okay. After dropping the coil tubing, the remaining assembly which shut in, which providing the seal, can hold the pressure. Like if we like the shear ram in BOP cannot hold the pressure. Its function is to only cut the pipe, and the blind ram can hold the pressure.
Yeah, it is different. This is the difference also between that one and that one. Right, you are right.
Yeah, sure. In shear seal BOP, can the rams hold the pressure as well, or it can cut the pipe only?
It cut, after cut, it will seal because the coil tubing will be dropped. So it will seal, have a seal to seal the pressure for the well.
Okay, so kind of a RAM for what we have, the RAM for combi BOP, blind shear BOP, similar to that one.
Yes, similar to that
It
one.
can cut and seal the BOP as well.
Yes, you are right.
Okay,
Yes.
okay.
Yes.
So Ahmed, this shear and seal BOP also acts like a brine.
Yeah.
What?
Single ram BOP, which is used for a shear and seal purpose.
Yeah,
After
this is
cutting.
Yeah.
After shearing, the coil tubing will fall into the well, and the seal will be not against the pipe. It will be just like a blind ram. Yes.
Yeah. So it's look like blind ram. Yeah. Yes.
Okay.
Yeah. This one.
Why do we need to have this BOP when we have a BOP above to cut the pipe?
Because if you have leak below the quad BOP, severe leak, the only way is to control by shear seal above the wellhead, right?
And if we have a leakage between shear seal and Christmas tree, then what we would do?
What you will do if you have leak below the shear seal, right? You will cut, you will go off bottom. If you are on bottom, you go off bottom little bit for space. Then you will cut with shear seal, but you still have leak below. So the coil tubing will drop below the Christmas tree valve. Then you close Christmas tree valve to secure the well.
Okay, fine.
Okay. In the API for coil tubing, this one should have separate control panel. It's different from the quad BOB. And also it will be in little outside location or in different location in control panel, this one with the ESD to cut at this last option to cut and secure the well in case of flow out or uncontrolled exit of oil and gas as a surface. Position immediately above the Christmas tree without any connection below. Why?
To get a maximum approach for cutting the coil tubing string?
No, it's not like this. To not have any connection or possible leakage path. So we need to put install direct above the Christmas tree. So
Okay.
you reduce the chance for any leakage below. That's why the last option. So we need to put install direct above the Christmas tree. Okay.
Okay, Mr. Ahmed, I have a question. We had a situation back there at a location where we weren't able to assemble the BOP directly above the Christmas tree due to the less height of rig floor. The rig floor height was too much low, and the swab wall was there wasn't enough space between the Christmas tree and the rig floor so that
Okay.
we can install a POP between them. So can we rig up a riser first above the Christmas tree and to get the access above the rig floor above the RTKB, and then install the BOP above riser, or we need to install it is mandatory to install the BOP above Christmas tree?
Which BOP, quad or the shear seal?
If we don't have if we don't have the um, space to install even tertiary BOP like the shear seal BOP, then what we should do?
In this case, so why you install riser? Because you cannot operate the BOP or connect above the Christmas tree.
Actually, the space between the RTKB, the rig floor, and the Christmas tree was too much low, and we
Okay.
couldn't able to install the BOP there.
So you install riser above the rig floor. So above the rig
Yeah,
floor.
there was an approach. Yeah, there was that it was we had installed the BOP first. Since it was really difficult to rig up the BOP just above the Christmas tree, but we go for that option. But can we rig up riser first
Yeah, we
above the
can.
Christmas tree?
We can, yeah. This is according this situation. We must do like this because we don't have option because the space out in this area. So you'll put section for riser, and then you install the BOP above. But in this case, this section will not include in the length for tool strength. You will count from above the BOP for lubricator above. Okay?
Yeah, I got it. I got your point. In case of fishing operation, we need to install the risers above the BOP according to the length of fish.
Yeah.
I got that point. But we can install the riser first and then the BOP above.
According to this situation, yes, we can. But you know, the connections below may be possible leakage path if it's happened. So the last option here is to, if you have leakage below, you will cut or drop the coil tubing, then you close the Christmas tree valve.
Yeah. Okay. Is there anything like we can install the riser above the Christmas tree, but the connection should be flanged or anything like this, or we can have a quick connection as well?
No. ABI standards, all connection for coil tubing is ABI flange. We cannot use quick connection. We cannot. The top for Christmas tree is quick connection, Acme thread. You will remove this flange and you install another flange to connect your pressure control equipment. It's not allowed to use any quick connection.
You know, sometimes in DST, in the case of DST, we have flow head. We have to rig up the equipment on the flow head, and we have a Acme connection at the DST at the flow head, at the top of the flow head. You will know that.
Where the flow head? In which area? As a surface?
Yeah, at the top. Just like the Christmas tree, we have a Acme connection at the top of flow head as well. In the case of DST.
Yeah. Okay.
We have you are saying, according to you, as per APS standards, that connection should be removed and BOP should be installed directly above the flange, connected with the flange connection.
Yeah.
But in some cases, we have, according to our standards, we nullify the use of quick connections after category 2 operation. Like we cannot install quick connections in category 3 But we
Okay.
can have a thread connection in category 2, like where we have wellhead pressure between 3500 to 7000 psi. Okay, fine. We can have a quick connection of thread and box connection.
Quick connection for all rigging up for coil tubing, or just this connection only?
Just this connection.
This
Or
connection
the
only.
connection.
Yeah.
Yeah, this connection or the connection above the BOP to connect the stripper with the BOP.
Okay. This one you can use, but according to the API recommendation, we need now all the connection to be flanged, API flanged. If the policy for or the instruction for your company according to the category, you can, but you know this one is not API recommendation.
Okay, fine. According to API, for coil tubing, all the connections should be flashed.
Yeah.
Okay, fine. Thank you.
Okay, thanks. So this one is shear seal actuator. Okay, for the shear seal ram. Another type which we talk is annular preventer. Like the BOP, normal BOP, the top section is packing element from inside. This is sealed with tubing or without tubing. Sealed around any size for pipe or bottom hole assembly. Usually when you have deployment for long bottom hole assembly, we can use this one below the stripper assembly as optional. Optional we use when you record, you will have pressure to close or open around various size or from bottom hole assembly or pipe. But this one is not replacement for the stripper assembly, because this one we use to apply pressure during static condition, while the stripper assembly is sealed while moving the coil tubing through. Okay. This is the cross section. You will find here piston. The piston will take pressure, hydraulic pressure to close. It will be pushed up, squeeze the packing element to seal around the pipe or size, different size for bottom hole assembly. This one cross section for annular, piston, packing element, head and body. This is the opening port and the closing port. You give pressure, so pushing the piston up, make squeeze for the packing element to take the shape for the pipe or the assembly or bottom hole assembly. Then you apply pressure in a static condition to release the piston pack, so retract the packing element around or away from the pipe. This is optional in some cases for coil tubing rigging up. This is how to select the packing element for the annular. We have different types: natural, nitrile, and neoprene. Nitrile and neoprene, this one is suitable with oil or oil-based mud fluid, because this is resistant to the corrosion. But in case you use only brine, this one is suitable with water-based mud fluid. So you select according to the fluid inside the well bore and according to temperature. Nitrile is used in high temperature and neoprene is used in low temperature area. This one is floaty or pump and sub. Usually we install here below the BOP, quad BOP, and above the tertiary ram or shear seal. We can use this one for bleed off, we can use for normal circulation or take return from the well instead of take return from the Christmas tree. Why? To not make more circulation through the Christmas tree valve, or to can make erosion for the valves for Christmas tree. So prefer to use this one as primary pass for the circulation. To allow for bleeding off fluid and gases and assist in the introducing fluid from or back from the hole. This pump.
I have a question here.
Yeah.
In the previous slides, where we have seen the procedure to cut the pipe, to shear the pipe. We have seen that first we should apply the slip rams, and then apply shear ram, pick up to fit coil tubing, and then close the blind ram, and then we will go for the fishing operation. If I talk about a specific scenario in which we don't have this floaty or pump and sub, we have a shear seal BOP just above the Christmas tree, a quad BOP above that tertiary BOP, and then the stripper. We have sheared the pipe, and the well is still flowing. We need to kill the well, and we need to pump through the kill line at kill port of BOP. So the how we have applied the slip pipe rams below. Slip pipe rams doesn't hold pressure from above, but they would provide any restriction for the pumping fluid coming from the kill port of BOP. So
Okay.
the kill string, the coil tubing pipe that slip pipes have hold would be acting as a kill string.
Yeah. If you need to kill the well after you cut with quad BOP, then
Yeah.
still close the slip and pipe ram. This
Yeah.
point give you access to pump through the coil tubing, through inside the coil tubing. Why? Because
But it, yeah.
the shear ram is designed to cut smoothly the pipe without damaging the top of the coil tubing. So you may be able to access and to pump through the coil tubing itself.
Okay, fine. But that was my question. Like, if after sharing with the shear ram, if we have a taper section or the damaged portion at the top of the coil tubing, then it would be the fluid wouldn't be going through the coil tubing as well.
Yeah. If the top for the coil tubing is for any reason is damaged, so you will not
Yeah.
use this one. So you will now we can pull heading from the Christmas tree at that time, for example.
Yeah, but sometimes we don't have the access to the kill wing valve in the Christmas tree as well. So we would pump through the that line only.
Which one? Floaty?
Yeah, we should install floaty, but if we don't have a floaty and we don't have a kill wing valve in the Christmas tree as well, where there is only one line which is flowing valve, which is going towards the flare pit or towards the plant side. So
Okay,
we need to.
why you don't have wing valve on the Christmas tree? Why?
We have some. I have done some jobs on the Christmas trees where we don't have a kill line side at the Christmas tree where we install a floaty above the Christmas tree.
Okay, you can for emergency you can attach one valve to the kill line valve or wing valve, one side, to have access to the well pool.
Yeah, I got your point, but if I was
So I
discussing a
question
specific
my question now. How
Yeah.
you perform pressure test on the shear seal in this case? If you install shear seal, the only option to pressure test shear seal from wing valve of the Christmas
from
tree.
below.
From below.
Yeah, I know, Mr. Ahmed, I know. But since I've already told you that we usually install one BOP above Christmas tree.
Mm-hmm.
We don't have a tertiary BOP above
Yeah,
the
I
Christmas
know.
tree.
Actually, Ahmed, we can perform the pressure test of the shear seal BOP by connecting the line to the flow wing, pumping line. Or might be if the flow wing is connected to the choke, then we can connect the pumping line to the choke as well, and close all the valves of the choke and pump towards the BOP. Close the swab valve, close the shear seal BOP, and pump from the choke.
It's depend on situation, but for minimum requirement, you need to have wing valve for Christmas tree. For normal rigging up, you have shear seal. If you have to pressure test from below, or if you don't have, you can install like another valve here with flange below, like two wing valve related to the cold tubing to be able to pump from this side. If you cannot connect on the Christmas tree itself, below the
Yes,
shear
Mr.
seal, I
Ahmed.
mean. Okay.
Yeah, I got your point. I was discussing a specific case in which we don't have a kill line on the Christmas tree. We have a one side flowing well, which is flowing towards the plant, and we have rigged up the equipment above. In that case, we need to install a flow T.
Yeah.
Through which
Yes.
we take returns through choke and flare, which is connected towards with the flare pit. In this case, we need to attach a line with choke so that we can kill the well.
Yeah. Yes.
Yeah.
Here, this flow T must have two isolation valve minimum requirement.
Yeah.
One is manual, and in the inside and outside one is controlled by hydraulic pressure. Okay. This one is manual.
Yeah, one is manual valve and one is the hydraulic pressure.
Hydraulic, like HCR valve in the BOB side outlet, is controlled by hydraulic pressure from the accumulator, or two isolation valve manual. But we prefer to have one at least HCR, like HCR hydraulic valve. Open and close, like the BOB open and close line, to open and close in fast way.
Yeah, fine, Mr. Ahmed.
Okay. Here, this one we said yesterday, this one, to not damage the top valve or swap valve for Christmas tree, we can install this one which is called isolation valve, if you remember. The isolation valve or two-way valve, this is hold the pressure from top and bottom. So we can apply any pressure against this valve to extend the life or not damage the swap valve for the Christmas tree. If you don't have this valve for the cold tubing operation, you can install double valve or valve number 2 above the primary swap valve. So the pressure will be again at this valve. If it is failed already, after rigging down, we will remove from the wellhead or Christmas tree. Okay?
Okay, fine.
All right. Here, this is the, you find here quick union connection in some situation like low pressure, but according to now the API recommendation, we're not allowed to use quick connection. This is like configuration for medium pressure, gooseneck, injector head, stripper only one, flow cross here, quad BOB, shear seal BOB above the Christmas tree. In high pressure, like 3,500 to 7,000, it is flange connection. If you look, he will make double protection, injector dual stripper, here used in high pressure and corrosive environment especially, as we said. Annular BOB optional, quad BOB, one quad, and flange here riser, flow cross double isolation valve, then again quad, another quad BOB, and then above the wellhead is shear seal BOB. This is extra precaution in some classification for configuration for the BOB. It can vary from policy from company to company based on the pressures or based on the job you are going to perform. Okay, this is just example. Yeah.
Okay. Ahmed, what is the 0.7 flow cross double isolation valve?
This one.
Yeah, this one. Flow cross double isolation valve.
This one.
7. No, why we install it? What its purpose?
If you need to, here you pressure test. If you need, for example, to pressure test this upper BOB, you will apply pressure from bottom. Okay. Or if you need for circulation or bleed off pressure between two BOB. So it's optional. Okay.
I have a question. Like, you have mentioned 3,500 psi to 7,000 psi. What is the which pressure? Like, is it wellhead pressure or bottom hole pressure?
Wellhead pressure, surface pressure.
In
This
case
is
of
based-
oil and gas well, both?
Yeah, I think, yeah, the same. But I think 7,000 psi is gas well. You cannot find oil well 7,000 psi. It's too much, I think.
I think for 3,500 to 7,000 psi, as per our standards, as per our sprint standards, like our company standards, this pressure is maximum expected wellhead pressure of well, and in case of oil well. But if you are in the case of gas well, then you would take the bottom hole pressure.
No, all selection for the POP or configuration for pressure control equipment is based on the surface pressure. You will go to the wellhead after stabilization. If the pressure like 4,000 psi, you will follow this procedure for the revving up. It's not talking about bottom hole pressure. Because why? In gas well, when you shut in the well, you will find maximum pressure you can read at the surface in gas well. Why? The difference, this one between formation pressure and the hydrostatic head inside the well. The hydrostatic head is gas, is light, compared with oil. So the maximum surface wellhead pressure or protected, it will be when you shut in pure gas well.
Don't you think, Mr. Ahmed, that if we are taking the bottom hole pressure, then we are going towards more safety? Like bottom hole pressure would be more than the wellhead pressure.
Yeah, for sure. But all selection
yeah.
for BOP, the BOP here is controlled surface pressure, contained the surface pressure as a surface. Does not contain bottom hole pressure. When you shut in.
No. I wasn't saying that it is going to hold the bottom hole pressure. What I was saying that in gas wells, we would take the bottom hole pressure to check that whether it would rely in the high pressure PC stacks or in the low pressure, medium pressure PC stacks. In gas wells, we would check the bottom hole pressure to be relying in both categories.
Okay, it is up to the policy, but what I know in most policy, it is just surface pressure. We need to check, because if you add the hydrostatic head for the gas, it will not give you too much pressure, because maximum pressure at the surface here will be difference between formation pressure and the hydrostatic head to the TD or TVD for the well, which is gas.
Okay.
The gas like 2 bbg, okay? 2 bbg, for
Yeah.
example. 2
Mhm.
bbg. Let's calculate 2 bbg at 10,000 feet. 10,000 foot, 2 bbg by 0.052. It
Oh,
give
2
you
bbg.
like 1,000 psi more.
Yeah.
At 10,000. If your well is 10,000 foot. Okay.
1,040. Yeah. Okay, fine. Now you are saying that if this is the wellhead pressure, apart from whatever the well type is it oil well or gas well, we would take the maximum expected wellhead pressure only.
Yeah, maximum expected. Why? Because you may go for to do some stimulation job. Okay. So the expected pressure after stimulation, maybe the wellhead pressure increased by 500 or 1,000 psi. So that's why usually it is written maximum anticipated surface pressure during operation. The maximum pressure you can reach maybe is higher than the shut-in wellhead pressure after you do stimulation job. So that's why you will go through the maximum protected surface pressure if you are going to do some stimulation job. Okay.
Okay, fine, Mr.
Okay. Now again, this is to remember primary barrier here is tripper, secondary barrier is quad or compi BOB, normal BOB, and tertiary is shear seal. How we can pressure test pressure control equipment? We need to apply pressure test external source. We cannot pressure test with the pressure for the well. This is not safe, because if you have any leakage, so you will escape oil and gas at the surface and it will be out of control. So we need to pressure test all barriers, all components, till the criteria, all the procedure for pressure test. The coil tubing now barrier is from outside to secure around the coil tubing, right? So the primary, it will seal around the coil tubing from outside, from anodes area. The secondary is BOB, sealing around the pipe. Tertiary is the ability to cut the coil tubing. What are internal barriers for coil tubing? To hold the pressure from inside the coil tubing to not
Check
reach to
valves
the
and the
surface.
BHA.
It will be
Check valves and the BHA.
two check valve, which is the primary barrier to seal from inside the coil tubing. So we need also to have dual check valve in the bottom hole assembly and must be pressure tested by inflow test. Okay. What is the secondary barrier in this case? This is the primary. Where's the secondary barrier?
The real isolation valve.
Which one?
The real isolation valve.
So if you have leak in check valve,
Oh, okay, okay.
what is the secondary barrier?
Could be the hydrostatic head that we can pump inside the coil tubing.
Yes,
No,
the fluid inside the coil tubing.
We have oil in the coil tubing.
Sorry?
We have oil. The oil is flowing.
Okay. We don't have any second barrier then.
If the coil tubing reel is connected with the pump, then the pump at the surface is the secondary barrier.
If you have leakage at the surface because you have hole at the surface or leak and the check valve is not holding pressure. So the primary barrier now is failed, internal barrier. What is the secondary and tertiary barrier in this case to secure the pressure?
Okay, the space with
The kill fluid that we can pump.
No, the secondary barrier here will be the shear ram of the quad BOB. In this case, you will shear the pipe to stop the leak at the surface. The tertiary barrier here will be shear seal above the wellhead.
Okay, okay, fine, fine.
This will
Yeah,
be
I got it.
internal barrier in sequence. Two check valve. You cannot continue operation if the two check valve is leaking. You need to replace it. You need to pull out to change. If it is you have leak at the surface and two check valve is not holding, so secondary barrier will be shear in the quad BOB. Tertiary barrier will be the shear steel. In some job, we need to reverse out circulation during some operation, right? So in this case, we will remove the two check valve. Now we don't have any internal barrier if you have leak at the surface and the pressure inside the coil tubing. So what is the primary barrier in this case? Internal. If you remove the check valve, you will lose the integrity inside the coil tubing because the dual check valve hold pressure from below of the well. In case if you need to reverse out,
shear ram would be the primary barrier in this case then.
Okay, shear ram in quad BOB is the primary barrier.
Yeah.
What is the
And shear
secondary
seal
barrier?
would be the secondary barrier.
Yeah,
Shear seal would be the secondary barrier.
And in some recommendation, according to the API, in this case, they ask you to add additional shear seal to be as a tertiary barrier.
Okay, okay.
Okay. In some condition also, if you are going to kill the well in this case, so the kill fluid will be in some cases primary barrier instead of the check valve. Okay, but if you don't have kill fluid, so first it will be shear of the quad, shear seal secondary, and double shear seal, it will be tertiary or third barrier. Okay. When you are going to pressure, yeah.
Mr. Ahmed, we used to have a double flapper check valve in the BHA.
Yes.
Like it's one DFCV, it's one check valve tool in which we have two cartridges of flapper.
Yes.
You get my point? Like we have one tool of check valve in which we have two cartridges with flappers. Like we have two cartridges of flapper which makes one check valve. So
Yeah.
we are installing one check valve with two flappers. So that would be double barrier, or we need to
No,
install
no.
two check valves, which gives four flappers.
No. The check valve is not two barrier in this case. It is only one barrier, but double.
Okay. So we need to install two check valves.
What mean two check valve? This is two check valve, flapper, and above that one another flapper valve.
So that would be two. This means, according to you, this would be double barrier.
This will be one barrier but double protection.
So what we need for in the case of coil tubing for the inside flow, we need two barriers or one barrier with double protection.
No, one barrier with two flappers.
That would be enough.
Yeah. You cannot, if you have leakage in the bottom one, you will not observe anything or any build up at surface because the first one or the top one is holding. But you can see building pressure at the surface if the both flapper is failed, right?
Okay. Yeah. Okay. Fine. And so that we can run one barrier with double protection.
Yes.
Okay. Fine.
And this is one question in the exam he asking about. If you have leak in the lower flapper, do you will see any leakage or build up pressure at surface? No, because the top one is still holding the pressure. So we need both is filled to see building up at the pump pressure at the surface. Okay. To perform a pressure test, we need to use water for sure, because it's incompressible fluid. Perform first low pressure test on seals. It will range from 200 to 250 or 300. Then you will go to high pressure test. All pressure tests must be solid line recorded in chart or graph. Pressure test should be in stages on the site. How much pressure, high pressure you need to perform in the pressure control equipment for the coil tubing?
We usually perform 1.5 times of the maximum. That is written 1.2 to 1.3 of the maximum wellhead pressure. We used to perform 1.5 times of the the 1.5 times of the wellhead pressure or the or below than the collapse pressure of coil tubing.
Okay, so usually in some company they did already in the workshop offline test on the test stump, so and give you the chart for that one. In location, there is some recommendation to pressure test pressure control equipment. Some company follow this one, and some company insist to do full pressure test each time, mean to the maximum pressure, even the Christmas tree or any lower pressure, to the maximum lower pressure. So here in some recommendation, 1.2 to 1.3 from the maximum expected wellhead pressure, or 10% in some cases above the maximum wellhead pressure, or rated working pressure with pressure control, or the less, usually the Christmas tree. This is recommendation. Okay, why we recommend to do 1.2 or 1.5 from the maximum? Because if you are working with 10K, for example, or 5K, and wellhead pressure is 500, we don't need to go up to like 3000 psi. We go like 1.5, like 750 or 1000. Why we do like this? Why this recommendation? Because they said more pressures, repeated pressure on the body or the BOP, that mean more fatigue to the material. So that means it reduce or derating or reduce the thickness for the BOP coil tubing. That's why this recommendation in some company we follow. Okay. Some pressure.
You got it.
Yeah, some pressure test use mixture for water and glycol, 60 to 40% from volume, to prevent the formation of the gas hydrate. And we don't recommend it or not allowed to pressure test the cold tubing with nitrogen. If you are going to lifting oil with nitrogen, you will purge the cold tubing with fill with nitrogen, and don't use the nitrogen because it is make erosion in the pipe and reduce the life for the cold tubing. So what is the steps or the procedure for pressure testing the cold tubing system while rigging up? First, we rig up the shear seal ram above. So this is the reel. This is the external source for the pump. This is the bleed off line. So first we'll go to pressure test low and high, the surface line to the inlet for the coil tubing. And we pressure test from the wing valve, open the crown and close the bottom one, pressure test the shear seal from the bottom. This is the first test we apply from the Christmas tree valve. That's why it is important to connect on the wing valve to the tree to be able to pressure test the shear seal if you are going to install above the Christmas tree. This is the first test. Second test, pressure test reel against test cap. After you connect the connector, cold tubing connector, for sure you apply maximum pull to the connector to check its integrity. After that, you can install test cap, so you can be able to apply pressure for surface line, including the reel of the cold tubing, all the cold tubing after flushing for sure, and you apply pressure to the end for the test cap. At that moment, you pressure test the reel for cold tubing after flushing, and for sure you drop the maximum ball to be sure this is cold tubing out of any obstruction.
Mr. Ahmed, why do we have 4 isolation valves in the treating iron?
Which area? This one?
Yeah, these are 4 valves. Why do we have 4 valves?
This
We
one
could
is
have 1 or 2 as well.
this one is for bleed. It is just a contingency. It's just a figure. It's not.
Okay, then this okay. It depends upon the rig up that how would we perform how we draw the line towards Christmas tree.
Sorry.
It depends on the situation that how we draw the line towards Christmas tree.
Here, if you are going to pressure test from the reel, you will close
Yeah.
this one. If you are going to use from the Christmas tree, you will open both, and there is here release line, and this one connected here or connected to the POP, to kill line and the POP.
Okay, fine. Then this means that there isn't any thing special regarding these 4 isolation valves.
No,
You could
it's
have
not.
2 or 1 as well.
It's
Okay,
not.
fine,
It's not.
fine.
You can make, but at least you need to have double protection, just in case. In well control, we just follow the double protection procedure.
Okay, fine.
All right. Number 3, or test number 3, we pressure test blind ram and lubricator section. So all pressure tests should be applied through the reel, except the blind ram and shear seal. Okay, so here in blind ram, you will apply pressure test here from the yellow point here, from test line from the wing valve for Christmas tree. So the pressure will go up. Okay, so you closed already the blind ram, so it will be below, from the below the blind ram. Except these 2 rams, blind shear seal, all pressure tests recommended according to the VI to be through the reel. Okay. Number 4, we need to pressure test the stripper assembly. So we apply pressure test through the reel, down here, against closed shear seal, so the pressure will coming through this area around the stripper assembly. First, you will take air, then you adjust the pressure to confirm the stripper is sealing the around the coil tube. Pressure number 5 on pipe ram. So the same, you apply pressure test through the reel, down across closed shear seal or top valve for Christmas tree, Then the pressure will back here. You close the pipe ram, the pressure will be below pipe ram. Now you have pressure in the system, all the system. So we need to pressure test the check valve. We need to check integrity for a check valve by inflow test. How we can do this?
We can
Bleed the pressure from the reel.
Yes, we'll start to bleed pressure from the pump to certain value or to 0. Okay, then we check building up pressure at surface. If not building up, that means the pressure from below the check valve is holding the pressure and everything is okay. This is the way, but make sure to not exceed the collapse rating for the coil tubing. Now we are going to check what is the coil tubing bottom hole assembly or the standards for bottom hole assembly. Bottom hole assembly configuration from top to bottom, standard and sequence. It will be coil tubing. It will be coil connector. The coil connector, you should make test on that one, full test to the maximum. It can be external or internal according to the job or the minimum restriction inside the tubing. Dual check valve, 2 check valve, usually flapper type. After that, the release sub number 4 below, circulation sub number 5, and then a special tool according to the job. It can be motors, it can be jet nozzle, bull nose, bridge plug, logging tool, perforation gun. But till here, this is it will be in sequence. Must be like this: connector to check valve, release sub. This is used in case of stuck. You will apply drop ball and you apply pressure to disconnect from the release sub and going up with the coil tubing and lift the remaining bottom hole assembly inside the hole. Circulation sub. This is you drop another ball below, so you apply pressure to open the circulation sub. That's why the circulation sub must be below check valve. We cannot put this one above, because in case we're using that one, so the check valve will be useless. Any fluid will pass the check valve and enter the string. All right?
Yeah, fine.
This is different types for connector. Temple connector, this is first one. It can be external or internal based on the job. This one, they have set screw and seal heel to seal between the coil tubing and the connector. And here you can connect your bottom hole assembly. This is the dimple tool used to impart dimples on the outside surface of coil tubing. Another type is called grapple, like the grapple for fishing operation. This one most common for coil tubing operation, the grapple connection, and also have set screw and seal O-ring here. Another type is called roll-on connector. This one using crimping tool to perform this shape for the connector. Usually this type is used in low torque and low tensile strength. Light job is not make or required any rotation or heavy job inside the wheel pool. Which type of common use with your operation?
Roll-on and dimple connectors.
Which one? Dimple?
Dimple and roll-on both.
Dimple and roll-on connect. Okay. This one is a special connector which is called electrical connector. This is to pass E-line inside the coil tubing to send signal through the connector to downhole tool, especially when you are going to perform perforation or logging job. This is the standard tool coil tubing check valve. There is different types for this check valve. The most common type is the flapper check valve. Why you use the flapper? Because it's easy to drop any ball circulated behind to open the flapper and pass the hole through to any tool to activate the release sub or the circulation sub below. So you have ball check valve number 1 here, dart number 2, look like also the same like ball. Third one is the most common is flubber check valve, and this one number 4 is spring type for check valve. Number 5 is pressure retaining the check valve. This one is release sub. Usually the release sub, you have different activation for release sub. First one is pole operated release sub. You drop pole launching on the inlet for the coil reel. Then you apply pressure through pumping behind capacity for coil tubing. Then the pole will start to drop in its place. So after that, you build up the pressure and over pull pressure up till release. You break this screw, so you're pulling out with the from here to surface, and you lift the remaining with the stuck bottom hole assembly. Another type number 2, this one pressure actuating release sub without dropping ball, but is work in differential pressure only. This one rely only in tension. You have some overpull to activate or release the release sub here and going up with the free coil tubing. This type is not common use because you may exceed and release the string accidentally without nail. So this type is not common use. We rely only on the ball one usually, which is called hydraulic release sub, because we drop ball and apply pressure to release. There's some special tool here for reverse circulation or mole show, or drill motor for fishing, drill pit for drilling, slim hole, blind box for fishing, casing cutter, under reamer to extend the hole size. This one, a special tool, I don't know you used before or not, it's called CT tractor. Do you know this tool?
Which one? Casing cutter?
No, this one.
CT tractor.
Tractor.
No, we didn't use this.
This one, like roller, working with pressure from the surface, special tool. Why we use this one? We activate by pressure from the surface, differential pressure. So the roller here will be out from its place to try to give more push for the coil tubing, especially in highly deviated or horizontal section, to push down more to the maximum depth to record logging operation or do some job. This is called roller, the same roller for the slick line. Okay, but this one is operated by differential pressure. Another special tool is called MLT, multilateral.
Ahmed?
Yeah.
Please go to the tractor tool.
Yeah. You see this?
So it has some kind of balls around the OD of the tool. What is the purpose of it?
The purpose for that one, when you are going inside highly deviated or horizontal well, the weight for the coil tubing itself, it will not be able to push the string long distance inside the horizontal section. So we apply pressure from surface. So we activate this roller out. So it will, like car, it will be try to push the string away to maximum distance or maximum depth. Okay.
Okay. Where we install it? Above the
bottom
below
hole
the
assembly.
check valve, or
no, above the bottom hole
just at
assembly.
the bottom?
Above the bottom hole assembly. You install bottom hole assembly, check valve and everything, and this is above. This one, another the special tool is called MLT, multilateral tool. If you have well multilateral and you need to select one lateral to go inside to do some stimulation job or logging, so this one you install in the bottom hole assembly above the tractor. Okay, it is working with differential pressure. This is special tool from third-party company. It's not related to the coiled tubing crew. So this one, it gives like you turn your pump and shut off again. So it will start to rotate the coiled tubing a little bit to find the azimuth for the required to enter selective zone. This is called MLT or multilateral tool. You work with this one before? Tower application?
No, Mr. Ahmed. But how we are certain that MLTs has worked correct and we are going in the correct lateral of the well?
Each pumping cycle, each pump turn on and off, it will, for example, rotate the string like 10 degrees. So you make many turns to select your tool. After you start to enter the selective lateral, you will find the pressure at the surface pressure will be dropped. So give indication that you are coming inside the selective zone or selective lateral. This is in simple way, but if you are looking for this one, I can give you some extra information about this one.
Hello?
In detail.
Mr. Ahmed?
Okay, why we use this coiled tubing tower application? This is hydraulic tower working with jacking system here in the top. Instead of using crane, we use this one to accommodate the length for lubricators in case of very long rigging up operation. So here it will be safe for rigging up the injector head for jacking on the top of the tower instead of hanging with crane. This is for more safe operation. Okay, Mr. Khawar?
Yes, Mr. Ahmed. Fine.
Okay. Do you use this one before?
Ahmed, have you read about the city tower application, or you are going to study this?
Yeah, this one. Safe, cost effective. We don't need crane. Hydraulic jacking system for rigging up long or high rigging up operation. I used this one time in Saudi Aramco for exploration well. We're rigging up long assembly for logging tool plus tractor plus MLT. Okay, so we're rigging up this sections of the tower application that time.
Mr. Ahmed, a tractor tool is only to push the tool below in the rat hole, or there are any other application for the tractor?
No, only to select to enter the lateral you need. You have well with 3 lateral. How I can confirm I go to select?
That was the MLT tool. I'm talking about the tractor tool.
You talk about tractor just to push.
Yeah.
Roller just to help to push to the maximum point you can go. When I use, if I hang on the horizontal section, I will pump to operate. Then I can push and going while pumping, and the tractor is activated to the maximum.
Yeah, fine. The problems of helical buckling related to the frictional forces that the drag forces that doesn't allow the coil tubing to go inside the well more in a horizontal section case.
Yeah, so you pull to you take the free picking up, then you apply that tractor system to try to push instead of make buckling for the coil tubing and fatigue or damage.
Okay, Ahmed, in the BHA, we install tractor above or the MLT above?
MLT, it will be in the top. Tractor close to the bottom hole assembly, then the MLT above.
Okay, thank you.
Okay. Now we're going to talk about coil tubing damage, fatigue, and failure. What is the causes can happen to the coil tubing, cause fatigue or damage to the coil tubing? First, there is some factor affect on the coil tubing life, like internal pressure while cycling or while bending. Spooling itself is not in correct way. It is effect of the pipe because of stress, storage and surface condition. If you are going to store the coil tubing, you need to apply grease and you cover the reel to protect from surface condition. Reel radius, as we said, when you increase the radius, that give lower stress based on the recommendation. The gooseneck roller, more roller give less stress on coil tubing. The alignment for rigging up, if it's not in center, that make friction for the coil tubing wall with the pressure control equipment from inside. Corrosive fluid like pumping acid, it can affect on the coil tubing life with the time. Axial load, tensile strength or hanging load. Traction pressure applied on the coil tubing to hold the coil tubing during pulling or running. It can affect also on the life for coil tube. First effect or the largest effect on the coil tubing during operation is the bending cycle. Here, the coil tubing is bent on the reel, then it will straight to the gooseneck, then it will bend again, number 2, then maximum bending here, number 3, then it will straight again through the injector head to run inside the well. Then again, when you're pulling out of the hole, the bending stress here will cause fatigue with the time for the coil tubing. That's why we need to adjust our rigging up or our operation to try to reduce the effect for the bending cycle or bending fatigue. Another thing can affect on the coil tubing life is the abrasive fluid pumping, like cement or sand laden fluid. Fluid contain sand, so it will make corrosion from inside and outside the coil tubing, shorten its working life. Another stress also is the tension or hanging weight. A lot of hanging, that a lot of stretch on the coil tubing. With the time, the coil tubing will deform, so it will go from elastic deformation to plastic deformation, and it can fatigue or damage or cut. Another source for damage is the buckling. As we said, the buckling can be two types. The first buckling we start with while slacking on, it will be sinusoidal buckling, this shape, S shape. If you are going to put more weight, you will convert to helical buckling, this shape for helical. That means you have locked up in this area. So putting more weight on the coil tubing, that means short the life for the coil tubing and more fatigue on the coil tubing. This one concept called ovality for the coil tubing. What is the meaning for ovality?
The
Roundness.
outside diameter of
Yeah,
the coil tubing changes.
a change in the outside diameter for the coil tubing. The coil tubing is take oval shape out of round. The acceptable percentage for ovality for the coil tubing before it rejected from surface, it is maximum 5%. If the percentage of ovality more than 5%, the coil tubing will be rejected. How to calculate the ovality? For sure, the ovality can be calculated by computer system during the inspection. This is the equation. Maximum OD after deformation minus minimum OD divided by the original or design OD. It gives you percentage for the ovality of the coil tubing. Because the coil tubing from beginning, from the manufacturer, it will not come 100% round. It still have some acceptable percentage for the ovality. The ovality, it can affect it with cycling first and with high internal pressure to take the shape for the oval. When the coil tubing become an oval shape, so the first effect will be the collapse strength. It can be collapsed because the thickness for coil tubing from outside will be less at the maximum OD in the oval shape. After that, it can be affected in the tensile and yield strength. Okay, gentlemen. What is the problem for oval coil tubing? What if I continue over 5%, the acceptable limit, during operation? What is the problem here related to well control?
Yeah, obviously, as you said, the city will collapse.
According to well control.
To well control.
The pipe ram may be not sealed around. The pipe if you have oval will not seal, maybe not seal completely around the section for the coil tube. But also, when you are going to pass over coil tubing over the gooseneck, it can hang or not pass the stripper assembly also. So that's why maximum or acceptable limit here, it is 5% in most company policy. Okay. This is another effect.
Yes, yeah, got it.
Or fatigue source, the injector here. If you look here, you will find here it is marked for the chain. If you apply more pressure, it can be source for damage on the external for the coil. This one is slip mark. After you close the slip ram, you see there is some bites here on the coil tubing from outside. With the time, it will affect this section from the coil tubing. That's why after you apply slip ram and the close pipe ram, you need to pull up to see visually if you have any effect on the coil tubing from outside or not. This one is the crack. It can be different shape here. The crack will not happen first for the coil tubing. The coil tubing start with pitting, small hole, then it will enlarge to be leaks or crack. Like this one, this is pitting, small hole, due to it can be internal or external, due to friction or due to corrosive fluid contact, like acid or stimulation job. It will make metal degradation. That means the thickness for the coil tubing will be less, and this is possibility for failure or fatigue. This is dent or abrasion or scratch source. Usually the scratch is coming when you are going in highly horizontal or deviated well, so the wall for the coil tubing start to lay on the low side for the inclination. Or if you contact sharp edges like wellbore or BOB component, so it can make a scratch or tint or abrasion due to abrasive fluid. So all this one is source for the damage. Usually spool and unspooling also, and loading and offloading can be, if it is not follow the corrective procedure, it can also cause damage for the coil tube. Okay, gentlemen. Clear?
Yes, Mr. Ahmed.
Okay, to this point, I will stop. And inshallah, tomorrow we'll continue the cold tubing part. We still have short section in cold tubing. Thank you.